Welcome to the second lesson of our WireGuard VPN course. Before we move to lesson 3, where we will start implementing our first site-to-site VPN tunnel, we are going to explore existing completed and fully functional network topology, so that we know what we should achieve in the end of this course, or what functionality we should achieve in the end of this course. After lesson 2 ends, I'm going to delete all VPN configurations, all policy and routes or routing tables, and all extra firewall rules. And I will just leave default RouterOS firewall rules with interface IP addresses and their related subnet masks. So let's start. Based on lesson 1, where we have explored our subnet mask and the topology, you already know how should the VPN work. We are going to test if it's working the way we planned or not. If it's working the way we planned, then it's fine. If it's not working in any case, then we should understand why. So let's start. I'll click on London PC. Berlin PC. We will log into London PC first. The default password is test123 with T, big letter T. And we will log into Berlin PC, test123. The DHCP servers, which are available on London office router and Berlin office router for the local area network, are going to assign the IP addresses based on the DHCP request of these two computers. So let's test the Berlin PC. You can see here it's written Berlin Win11 PC 02. Let's get rid of unnecessary windows. We say IP config. We see that the Berlin PC was assigned the IP address of 192.168.2.254 and the gateway is 2.1. So the gateway is 2.1 is this interface, as I have mentioned in the previous lesson. Let's try to ping some internet address. Let's say ping google.com. And you can see that the PC is able to resolve the address and ping the internet, and the ping goes this way. Let's check that the ping goes to the internet this way by pinging my second router, which is behind this internet network. It is located in the network of 192.168.11.1. It is pingable. Let's try to trace route it. We say trace route, and let's see how the route will go. As you can see from the trace route, the default gateway is 2.1 is the first hop, then 172.16.2.1 is the second hop, which is this interface on router ISP. Then it says 192.168.13.1, which is my home router, which is the internet interface of the ISP router, which is in the 192.168.13.0 subnet. Now I will connect to the ISP router and will show you all the IP addresses which are available on its interfaces. And then it goes to 192.168.11.1, which is even behind this, my home router. Let me connect with the Winbox. Let's refresh and see the neighbors. And somehow I don't see my ISP neighbor. My EVNG had some temporary error. Actually not EVNG, but the VMware Workstation Pro, most probably because of the too many Windows 11 Pros were running at the same time. So I decided to keep the number of the online machines to 3 for now, so that we don't get error again. So as you can see, I've opened 2 Windows computers, one of them from Berlin, which is from here, and the other one from London, which is from here. Actually, this is from Berlin and this is from London. On the left side from Berlin, let's maybe change their locations. On the left side from London, on the right side from Berlin. As you can see, the Berlin computer has received the IP address from the network of 192.168.2.254, and the London computer has received the IP address of 1.254. Let's see if they can ping each other. We say ping 192.168.2.254, and as you can see, the London computer can ping Berlin computer, but let's see how the ping goes. Let's say trace RT 192.168.2.254. As you can see from the trace route, it first goes to 192.168.1.1, which is the gateway of the London router. Then it goes to 10.10.10.1, which is the tunnel interface from here to here, 10.10.10.1. Then it goes to 10.10.10.2, which is a tunnel interface of the Berlin router, this one. And then it goes to 192.168.2.54, which is this computer, or the computer which we see on the right side, Windows 11 Pro. As you can see, the traffic is going through the tunnel. Let's check the IP address scheme on the ISP router computer. I think there should be a password. Okay, as you can see, we are using the latest stable version of the RouterOS 7.21. Let's see the interfaces. These are the interfaces, and these are the IP addresses. Let's compare. I have put names here. Ethernet 1 is Internet, and Ethernet 1 got the IP address from the range of 192.168.13.52, which is my home network. Ethernet to London. Ethernet to London is 172.16.1.1. Let's reduce the size of this Winbox so that we can also look into the topology while analyzing the IP addresses. Let's make it smaller, and the size that it's comfortable to see both. So Ethernet 2 says 172.16.1.1. Ethernet 2 172.16.1.1, so it's matching. Ethernet 3 16.2, matching. Ethernet 4 16.3. Ethernet 4 here 16.3, matching. Ethernet 5 16.10. Ethernet 5 is this one, 16.10, matching. Ethernet 6 16.20, it is here. Ethernet 6, it is matching. Ethernet 1 we already explored. Let's see on the Winbox terminal if there are any other configurations. Let's say export. As you can see, the ISP router has very simple configuration. The 6 Ethernet numbers, their IP addresses, DHCP client on Ethernet 1, IP DHCP client, which has received the IP address from my home network, which we consider in our topology as Internet. Then we have a masquerade rule, IP firewall, one masquerade rule here, which is hiding all our network topology behind the Ethernet 1. We have chain source NAT, out interface Ethernet 1, and action masquerade. That's all. Nothing else in the ISP router. And also we have set the name ISP router 1, and you can see here on the top ISP router 1 and its IP address. Okay, let's close it for now. So as you can see, the topology which I have explained you on the lesson 1 is matching with the ISP configuration in our lesson 2. Now let's try to ping the FTP server, which has an IP address of 192.168.3.100. 192.3.100. As you can see, we can ping from a London office computer the Berlin office server. Let's try to do the trace route to the same machine. As you can see, the trace route shows the router interface, then the tunnel interface, which is this one of the router in the Paris office, then it goes to the server. Let's analyze the Wireshark if this is the reality, if we have an encrypted traffic between these two locations. We will right click, say capture, we select Ethernet interface 2. It will open the Wireshark. If you face this kind of error while opening your Wireshark on one of the interfaces where you want to make a capture, you should renew your SSH keys. Let's do it. Let's say putty. Let's check the IP address, 13.68. Let's say lot. Let's say open. Let's say accept. Let's say root. Let's say EV. That should be sufficient. Let's check again. Capture. Ethernet 2. Open Wireshark. Yes, now we don't have any errors finally. It was sorted out. Okay, as you can see, we are capturing now from the interface number 2, which is this one. Let's do the ping from London computer. Test 1, 2, 3. Okay, let's say ping 192.168. Let's start the server. 192.168.11.1, which is somewhere outside of our local topology, which is somewhere there in the internet. And let's at the same time see what will happen in the Wireshark. Let's press enter. Let's make it longer, pings. As you can see, the Wireshark is fixing the ICMP packets. Let's make them larger size. For example, we will say -L1000. As you can see, we have 1042 echo pin request and response packets going through. and the Wireshark can see them. Let's cancel now. Now let's try to ping from our topology from this computer through the VPN server to Paris and this server, which ends with 192.168.3.100. And at the same time, we will look what is going on the Wireshark. Wireshark computer. We say 168.3.100. As you can see, we can ping the server. But the interesting thing is that, let's stop the capture. The interesting thing that, let's stop the ping here also. The interesting thing is that now the ping is going through the tunnel and it is encrypted. You see the packet size is 1114. Let's see what is inside. It says the protocol WireGuard and the packet is encrypted. We don't know what is inside. Actually, we know what is inside, but Wireshark doesn't know because the protocol is being encrypted. As you can see, the source port is 42761 and the destination port is 443, which is the port on our Paris router incoming port for the WireGuard. Okay, let's close the Wireshark. Now we have proved ourselves that the packet which goes through the tunnel from London PC to Windows server is encrypted. The same, all other packets which go through our tunnel should be encrypted. But now let's see from our topology if other packets working as expected. For example, let's open the Berlin computer, log in, test 1, 2, 3. And we will try to trace road till the server and see if the path is also through the tunnel. Then let's start one of the computers here. Okay, Berlin computer is on. Let's say trace route to 192.168.3.100. So it goes from Berlin. Berlin is this computer. It goes to FTP server, which is on the Paris headquarter network. As you can see, it goes to 2.1, which is the default gateway for that computer, then 10.10.10.1, which is the WireGuard interface on Paris VPN, and then it goes to 192.168.3.100, which is the server. Now let's see if we can RDP to that server. We will say search and say remote desktop connection. I have created two users on this computer. First user is Mary, the other is Bob. And their passwords, I think, were something simple. Let's say enter. And we are now trying to connect to the Mary's desktop. I think the password is test123 also. On Mary's desktop, I have created a text file with a name called Mary, and let's see if we can see it. While it's being loaded, let's try the London computer also to log into the server at the same time. Let's say remote desktop. The IP address is same, 3.100. And the username in this case is Bob, you see, and the password is same, test123 for that user. Okay, both computers are trying to connect to the RDP. Actually, they already connected, just trying to display us the streaming image. Hopefully we will succeed if nothing crashes. So it's loading to the Bob's desktop, and this computer is loading to the Mary's desktop. And yes, we are successful. From Berlin we have logged to the server, which is here, Windows Server 2025. And with the user Mary we see that we have a Mary desktop here, the text file. And we successfully logged to the same computer with the second user, user Bob. You see here we have a text file of user Bob desktop. So by default we can log just with 2 users at the same time on the Windows Server 2025. If we want to log with more users at the same time, we need to activate specific RDP configuration, which is out of scope of this lesson. Okay, so now let's disconnect. Let's see if we are able to access the command prompt from the server side. We can. Let's see the IP address of the server, ipconfig. And as you can see from the remote desktop, we see that the server has IP address of 192.168.3.100 with the default gateway of 3.1, which is exactly this network in the Paris headquarters. Okay, let's disconnect from the RDP connection. Next, we are going to test the connectivity between, for example, this site, which is our Barcelona home. Let's log in. Let's say test 1, 2, 3. And this computer, let's also start it. We will also be able to log into RDP server from this computer, because this network should be tunneled through the headquarters to the internet, so that we are able to access all the resources here and even in London and Berlin office. With the trace route, we are going to check it now. But this network is not connected to the VPN, and all our network activity with the internet will go directly through the ISP, and we will check it also with the trace route. Okay. Let's open the second PC also. While it's loading, let's do some tests with the home PC via tunnel. Let's open the command prompt. And let's try to trace route our internet IP address of 192.168.11.1, which is the router in the internet. And it should go like, you see 192.168.19.1, which is the gateway of this your home router. Then it goes 10.10.10.1, which is Paris tunnel. Then it goes 172.16.3.1, which is the Paris gateway of the ISP. Then it goes to 192.168.13.1, which is gateway somewhere here. Then it goes to 192.168.11.1, which is somewhere even behind that gateway. So as you can see, the computer which is here cannot go to the internet directly. All traffic is routed through the VPN tunnel to Paris. And at the same time, we can check if it can reach, for example, London computer 192.168.1.254. As you can see, the path is same. Just instead of going to internet, it goes to 10.10.10.1, which is the Paris, and then 10.10.10.3, which is the VPN interface of the London office. And then it goes to the 1.254, which is the London computer, which is active now. Now let's check what route will choose the Win11 Your Home PC No tunnel. This one. Let's log in. Test 1, 2, 3. Let's shut down maybe Berlin computer to reduce the load on the system. Let's say shut down. Okay, let's say the command line and let's say trace route 192.168.11.1. This is our home PC without tunnel. It goes 192.168.89.1, which is the gateway of our home router in the topology. Then 172.16.10.1, which is default gateway of the ISP. Then 192.16.13.1, which is default gateway at my real home router, which in our topology is internet. And then it goes to 192.168.11.1, even behind my home router. So as you can see, the computer which is located on the left side doesn't use any VPN connectivity via Paris or anything else and directly can go to the internet. This kind of implementation might be useful when you are at home and you have, let's say, two Wi-Fi networks. If you connect your work computer or phone to your work Wi-Fi network or work cable network, you will directly access your headquarters site or any other sites. But all other devices, which like your TV or any other non-work related IP devices, you can connect to your left side network, which is 89 in our case, so that they will go to the internet directly, bypassing all kind of tunnels which they don't need. Okay, and I will show you that the home network cannot ping anything in our network. For example, let's say ping 192.168.3.100, which is our server in the headquarters, and it cannot ping it. Why? Because it cannot access it. It tries to send the packets to the internet, but internet doesn't know about this address. As you can see, my home router says destination host unreachable. Okay, so we can close this one also to reduce the load on our computer. And the last client that we want to test in our topology is the road barrier, which will make a tunnel only when we activate it inside our computer. The computer is being loaded. By default, the road barrier computer will have access just to the internet. So in order for this computer to have a tunnel configuration, we need to activate it through the WireGuard client. We will check it now. Let's say test 1, 2, 3. So without WireGuard client activated, the internet traffic will go directly through the ISP. With WireGuard client activated, with a full tunnel, all traffic will go to the headquarters and then will go to the ISP. And at the same time, the full tunnel will be able to reach all the resources like FTP, RTP servers, and London and Berlin local areas. Plus, we have a configuration with a split tunnel, where we are able to tunnel all internet traffic to the ISP and only local area network traffic related to Berlin, London, and Paris office to tunnel through the WireGuard client. Let's see. Let's see what currently is going on. We say ping 192.168.3.100. And we can see that the destination is unreachable. But let's see if we can ping 11.1, which is router on the internet. Yes, it can ping directly like this way. Let's see the trace route, how it goes. As you can see, it goes to the 20.1, which is this interface first, then 13.1, which is my home router somewhere there, and then 11.1. So it doesn't use any VPN. Now let's open the WireGuard client, which I have already installed here. Let's find it down, saying WireGuard. Yeah, it's here. I have here 3 configurations. One of them is full tunnel and 2 of them are split tunnel. The first one is full tunnel. Let's activate it. And now again try to trace route to the same resource on the internet. As you can see, it goes to 10.10.10.1. 10.10.10.1, it goes to the tunnel here. Then it goes to 3.1, then it goes here, 3.1. Then it goes 13.1 there, and then it reaches the remote internet router. So with a full tunnel, all traffic goes through the Paris headquarters. Now let's deactivate it and activate split tunnel. With the split tunnel, the IP addresses which mentioned here, 3.0, 2.0, 1.0, and 10.10.10.0/24 are going to be tunneled through the VPN tunnel, and the rest IP addresses will go through the internet directly. Because our 11.1 is not mentioned in that list, it should go to the internet directly. Let's check. As you can see, it goes to 172.60.20.1 directly to the ISP, then to 13.1 to my home real router, then 11.1, which is the internet router. So with switch it on tunnel, all non-office related traffic, non-office subnets go directly to internet. But let's say we want to ping the London office computer, which is 1.254. Not ping, but trace route. And as you can see, that traffic is going through the tunnel. It goes to 10.10.10.1, which is Paris router. Then it goes to 10.10.10.3, which is tunnel interface on the London office. And then it reaches 1.254, which is a London computer. So by doing this kind of trace route and ping test, we can understand that the VPN topology, which we have built or created, is working as it should be. This is all what I wanted to show you in this lesson. If you have any questions, you can ask them in the comment sections of the video. On the next lesson, we are going to start building our first site-to-site tunnel, which will most probably will be from London to the Paris. What does it mean? It means that now I'm going to destroy all the VPN configuration, all routing configuration, all additional roads or policies or some firewall rules which I put here. I'm going to remove them. I'll just leave the IP address scheme so that we can start building the VPN topology step by step together with you. Hope this lesson was informative and see you on the next lesson. I highly recommend subscribing to my YouTube channel so that you don't miss any new lessons or setup guides that I release.